Section 8.4 is on special products. In this section, we are still multiplying polynomials, and in fact, more specifically, we're multiplying binomials, so two binomials. But sometimes with special pairs of binomials, you can actually use a shortcut. And so I would encourage you to memorize these formulas. The first one is called the square of a sum. So what we have is a sum, two terms being added together, a plus b, and that whole quantity is being squared. Now granted, we could write this as a plus b times a plus b and then use the FOIL method from the previous lesson, but there's actually a shortcut you can take. So if you have the quantity a plus b squared, that's equal to whatever a is squared plus 2 times a times b plus whatever b is squared. Similarly with the square of a difference. Here I have a difference, a subtraction going on in the parentheses here, a minus b, and that quantity is squared. Again, I could FOIL it, but if I memorize this shortcut, I just take a squared, and in this case it's minus 2 times a times b plus b squared, and it's a shortcut instead of going through all of the steps of FOIL. And the last example is the product of a sum and a difference. Notice a plus b is a sum, a minus b is a difference, and when I multiply those, I get a squared minus b squared. And the reason this works is if you take a quick look at the FOIL, a times a is a squared. When I do my outer, a times negative b gives me a negative ab. My inner, a times b gives me a positive ab. And those will cancel each other out, a negative ab and a positive ab. And then b times negative b gives me the negative b squared. So please memorize these formulas. It'll make not only this lesson easier, but in the future when we're undoing it and going backwards, it'll make that a lot easier as well. So let's take a look at several examples here. First one is the quantity x plus 5 squared. Now this is going to follow the formula a squared plus 2ab plus b squared, because this is the square of a sum. First thing I'd like to do is identify a. A is going to be x, and b is 5. Now all I need to do is plug those into this formula. So a squared is x squared plus 2 times a times b plus b squared, or 5 squared. Cleaning that up a little bit, I'm going to end up with x squared plus 10x plus 25. And that's my final answer. Now again, you could FOIL this, do x plus 5 times x plus 5, but you're going to end up with the same thing. And after doing this several times, you'll get used to it and it actually becomes a lot easier. Let's take a look at number 2. I have the quantity x minus 6 squared. So for this, I'm going to use the formula a squared minus 2ab plus b squared. And in this case, again, my a is x, and my b is actually a positive 6. Now you may be looking at this thinking, well, b is going to be a negative 6. But notice my formula, the original formula was was a minus b. So b is whatever is being subtracted from x. So let's fill these in. A squared is going to give me x squared minus 2 times my a times my b plus b squared. And simplifying that, I have x squared minus 12x plus 36. And my next example is 3x plus 7, that quantity squared. So this is again the square of a sum. So I'm going to use a squared plus 2ab. And notice there's a plus here because there's a plus here. There was a minus here because there was a minus over here. And finish the formula b squared. In this case, my a is 3x and my b is 7. So plugging that into the formula, I'm going to have the quantity 3x squared. Don't write it as 3x squared. It's the whole 3x that's going to be squared because 3x is what a is. Plus 2 times a, which is 3x, times b, which is 7, plus my b squared, which is going to be 7 squared. So to finish this off, 3x squared is 3x times 3x, or 9x squared, plus, that's going to give me 42x plus 49. Now my next example, notice I don't have anything squared. My example number 4 is x plus 11 and x minus 11. This is actually the product of a sum and a difference. And for this I'm going to use the formula a squared minus b squared. I actually kind of like these because they're pretty easy, pretty straightforward. So looking at this, a is going to be x and my b is 11 because remember the original formula said a plus b and an a minus b. So plugging those in, I'm going to get x squared minus 11 squared, or x squared minus 121. Example number 5, again, it's the product of a sum and a difference. In this case, my a is 4x and my b is 3. Plugging that in, a minus b squared, a squared minus b squared is going to be 4x squared. Remember, this was like example number 3, where if my a or my b, in either case, is more than just one term, more than just one number or variable in the term, I have to square the whole thing, minus 3 squared. 4x, the quantity squared, is 16x squared, and 3 squared is 9. And our last example here is 2x plus 9 times 2x minus 9. Again, the sum and difference of a square, so it's going to multiply out to a squared minus b squared. My a is 2x, my b is 9y. So I'm going to have the quantity 2x squared minus the quantity 9y squared, or 4x squared minus 81y squared. So in this section, we found that in certain cases you can actually use a shortcut to foiling two binomials. If you have the square of a sum, two things being added and squared, or the square of a difference, two things being subtracted and then that being squared, or if you're multiplying a sum and a difference. And I would strongly encourage you to memorize these 3 formulas. In fact, you can do as I did in the examples, and every time you do a problem, write out the formula. It's going to make it a lot easier in the long run to actually solve these problems, to simplify these, and then when we factor in a couple sections, it's going to make that a lot easier.